Assalamualaikum warahmatullahi wabarakatuh. We group 9, we present our section B part. That is about signal conditioning. So, I will explain you about a problem in our instrumentation system, so we can out with the solution. So first, our problem is at LM35 temperature sensor. So the problem is, first, the output voltage is too small. Next, it will susceptible to noise. So third, the LM35 temperature sensor output is an analog voltage that is linearly proportional to the temperature. So the solution, first, we can put the application such as use a non-inverting amplifier with N or M. So we can gain 5 times to bring the 0 to 1 voltage signal to 0 until 5 voltage range. So this can improve our resolution of temperature reading. So second, we can add low pass filter. So add a simple RC filter to remove high frequency noise. So let's go move to the next part. MQ9 gen sensor. So the problem happen here is, first, the analog output fluctuate due to electrical noise from power supplies. So this can cause unstable reading. Second, in clean air or at low concentration, the voltage may be around 0.1 until 0.3 volt, which is too low for good ADC resolution. Third, MQ9 has logarithmic response to gas concentration. This makes it hard to interpret raw analog values. Fourth, the internal heater needs a preheat time 2 until 5 minutes and stable voltage typically 5 volt. If unstable, sensor will give wrong output. So the solution we make, first, add a low pass RC filter between the sensor analog output and Arduino input. Second, use an op-amp amplifier non-inverting with gain 5 until 10 times to boost signal to usable range. Third, apply logarithmic conversion or calculation in software. 4, use a stable 5 volt power supply and a low warm-up time before taking measurement.
So next, I want to talk about our last problem, which is piezo buzzer and LED load driving. So what is the meaning of this problem is, the directly driving the buzzer and LEDs from Arduino pins may cause excessive current draw if using multiple devices, and last is voltage drop affecting logic level. So for the solution for this problem is, first, use transistor switching such as NPN transistor for buzzer and LEDs. Like we use the NPN transistor as a signal conditioning of this problem. And second is add flyback diode across buzzer if it's inductive.
Hi, I'm Muhammad Akibin Azman, and today I'll be presenting a comparison between the original and new Arduino code developed for our project. This project involves using gas and temperature sensor to detect hazardous conditions and trigger alerts like buzzers and LEDs. The original code reads analog values from a gas sensor and a temperature sensor. If the gas level is 250 or more, or the temperature is above 70 degrees Celsius, it turns on a buzzer and lights up an LED. While it works, this version has limitations where it does not handle sensor noise, the temperature formula is rough, and there is no way to monitor real-time values. So, the new code improves on these points. It uses a moving average to smooth out sensor readings and reduce false alarms. The temperature is now calculated using a more accurate formula based on the TMP36 sensor datasheet. We also added serial output to monitor values in real time and added proper control to turn off the buzzer and LEDs when conditions go back to normal. So here is a quick comparison. The first one is the new code is more stable thanks to the moving average. The second one, temperature readings are more accurate. And last but not least, the code is also easy to read, maintain and debug. These changes make the system more reliable and professional. Okay, so all in all, small improvement in coding can lead to better performance and reliability. This project shows the importance of refining even a working solution. That's all from me. Thank you for listening.
So now we go on to the circuit. As shown in the slide, we have original and the new circuit. So the comparison about the new and the original circuit is, at the new circuit, we have add the OPM and the NPN transistor as our signal conditioning. The purpose we add the signal conditioning is to smooth the circuit and give us the better result of the system, and we can solve the problem that we had just now. So after that, as shown in the slide, we have the real circuit that we built in the group. So this is the picture of our circuit.
So Assalamualaikum. So basically this project come up with the video simulation result. So let's enjoy the video. Okay. So as you can see in the video, there was a two type of sensor, which is a temperature sensor and the gas sensor. So as you can see, the temperature sensor will continuously monitor the surrounding temperature, where it will send the analog digital signal to microcontroller, which is a Arduino, so representing the current temperature. So if it detect the temperature higher than the predefined safe limit, such as 50 Celsius, so it will activate the activate the alert. So for the second sensor, which is a gas sensor, it will detect the concentration of the certain gases such as LPG, methane, carbon carbon monoxide. So it will send the signal to the microcontroller, which is Arduino again, proportionally to the gas concentration to the surrounding. So if the gas level exceeds the safety limit, so it will trigger the alarm. So the third device, which is a microcontroller, which is Arduino, it will continuously read the input from the sensor, which is from temperature sensor and the gas sensor. It will compare the reading to the preset threshold values. So if the reading exceeds the threshold, the LED will come out with visual light, such as LED light, for the visual indicator, and the buzzer will make a noise for the audible alert. So next, the result after adding the signal conditioning. So first, we can improve the gas sensor stability. So the software averaging, which is a low pass filtering on the MQ2 gas sensor, reduce noise and fluctuation, resulting in a smoother and more accurate gas reading. So the second, enhance the temperature reading accuracy. The addition of op-amp, which is a LM358, amplified the small voltage from the TMP36 sensor, allowing more precise temperature measurement using the full ADC range of the Arduino. So the third point is reduce false alarm. More stable and accurate reading ensure that the buzzer and the warning LEDs only trigger when the actual gas level or temperature exceed the safe limit. So the next point is a better use of Arduino ADC, which is a signal amplification slow. It allows small voltage to be better scaled to the Arduino from the 0 to 5 volt ADC input range, improving resolution. For the next point is improve system reliability. Signal condition make the entire monitoring system from the robust and suitable for real world use, which the consistent and reliable operation. And the last point is the real-time debugging enable. The addition of serial output provide live sensor value, adding in calibration, testing and troubleshooting. Thank you.